Hey, Mike from Prep Pros here, and for those of you who don't already know me, I'm on my 9th year of working full-time in test prep. I've scored perfectly on the SAT myself. I've helped students score perfectly, and many score in the 99th percentile, and I just published my second SAT math book, completely updated and revamped for the new digital SAT, which I think blows anything else out of the water. So I know a thing or two about helping students do really well on the SAT. So in this video, we're going to run through a super helpful exercise for you to ramp up your digital SAT math skills. We're going to take a look at the 10 hardest questions that Collegeboard has released for the new digital SAT. And I'm going to teach you some really helpful content, tips, tricks, and strategies, along with Desmos hacks for how to take some of those very complex questions and make them far more approachable. At the end of the video, I'm going to talk about some additional resources which can help you better prep for the digital SAT and get that perfect score that you're looking for. Function f is defined by f of x equals negative a to the x plus b. So this is going to be an exponential function where a and b are constants in the xy plane. The graph of y equals f of x minus 12, so this function shifted down 12 units has a y-intercept at 0, negative 75 over 7. The product of a and b is 320 over 7. What is the value of a? This is a lot of information to try to wade through, but what we always want to pay attention to is if you get any of these really difficult exponential questions, you're following the same series of steps we're about to go through. They're always going to give you a point that you can plug into. And what we always know is this first portion is our x value, second portion is our y value. So we can just start to plug this in. And we want to remember f of x is the same as y. So we can go ahead and rewrite this as negative 75 over 7, plugging in for y, is equal to negative a to the 0 plus b. But since the shifted down function had this point, we also have to bring in our minus 12. Now from here, anything to the 0 is 1. But one really important part here is this is going to be our exponents and this is our multiplication. Anything to the 0 is 1, but this is going to now be the same as negative 75 over 7 is equal to negative 1 plus b minus 12. So this is going to give us negative 75 over 7 is equal to b minus 13, which now means we need to add the 13 over. 13 in terms of 7 is going to give us 91 sevenths minus 75 sevenths is going to be equal to b. So that's going to tell us that b is equal to 16 sevenths. Now from here, we're mostly home free. The product of a and b is 320 over 7. Well, now we just need to set this up is what we know is a times 16 over 7 is equal to 320 over 7. So now we can just divide both sides by 16 over 7. You can use your calculator here, or we can multiply by the reciprocal, which is the same as 7 over 16. Our 7s are going to cancel out. 320 divided by 16 is going to give us our correct answer of a is equal to 20. Main point here, look to plug in the values if you get one of these on test day. Now, not all digital SAT math questions are necessarily as time intensive as the first one we went through or as technically difficult as some of the really crazy ones we're going to go through later in the video. Oftentimes they're hard because the SAT knows you're going to make a common mistake and you feel like you found the right answer, and then you end up after the test realizing you missed it. So I strongly recommend to pause the video here, see if you can find the right answer, then we'll break this down together. Now, if you picked B, you fell for the SAT's trap. So here we have a certain town has an area of 4.36 square miles. What is the area in square yards of this town? 1 mile equals 1,760 yards. So this is a unit conversion question. The SAT loves squared and cubed unit conversion questions because students mess these up all the time. So what we can think about is there's a few different ways we can go through this, but I'm going to do it one way that often feels simplest for students. So we have 4.36, this m here is just miles, and we're going to do miles squared since it's squared miles. If we want to convert it to square yards, what we cannot do is just simply use our conversion factor and do 1,760 yards over 1 mile. This is squared, so we need to square our conversion factor. So what we're really doing here is instead of simply 4.36 times 1,760, we're doing 4.36 times 1,760 squared, and that will give us our correct answer of D. The table shows three values of x and their corresponding values of y, where y equals f of x plus 4 and f is a quadratic function. What is the y-coordinate of the y-intercept of the graph of y equals f of x in the xy plane? Well, what this tells me is I want to find the y-intercept of this, and then I need to subtract 4 from it, and I can find the y-intercept of f of x, since this is shifted up 4. Now, this is the first of the three quadratic questions we're going to look at. The SAT loves quadratics for a lot of the really advanced questions. Now, there's one thing that's really important to understand so we can actually get started on this question, and this is that parabolas are perfectly symmetrical. So you might remember from math class, you have what's called an axis of symmetry, and if I drew this a little better, we'd have stuff equidistant on both sides, but parabolas are perfectly symmetrical. So what this tells me is this is my vertex, because as I go 2 units to the left and 2 units to the right, I have the same corresponding y values, and we're going to go over how to do this in Desmos, so that visual will help you if this isn't clicking yet. But this gives us a way of understanding that our vertex is 23, 8. So what this tells me is I want to use vertex form to start this question. So I'm going to do y equals a, and our vertex form is x minus h squared plus k. We don't know our a value, but we know our h is our x-coordinate of the vertex, k is the y-coordinate of the vertex. So we're going to do y equals a times x minus 23 squared plus 8. Now, we're stuck because we need to solve for a. Anytime we get these word problems, we're going to always have another point that we can plug in. We could plug in either of these points. I'm just going to go ahead and I'm going to use 21 here. Doesn't matter which one we use. So I'm going to plug in negative 8 for y is equal to a times 21 minus 23 squared plus 8. Well, 21 minus 23 is negative 2. Negative 2 squared is 4. So this is going to give us negative 8 equals 4a plus 8. Subtract this over. We will get that negative 16 is equal to 4a. And this will give us that a is equal to negative 4. Now we know the entire equation of our parabola. So now we know that our entire equation is negative 4, y equals negative 4, times x minus 23 squared plus 8. Now if we're looking for the y-coordinate of the y-intercept, we always find our y-intercept when x is equal to 0. So we just get to punch this in our calculator. We'll do y equals negative 4 times 0 minus 23 squared plus 8. So I'm just going to pop this in my calculator now. We'll get our negative 23 squared is going to give us 529 times our negative 4 is going to give us negative 2,116 plus 8 is going to give us y equals negative 2,108. But this was y equals f of x plus 4, and we're looking for f of x. So we need to subtract 4 from this, and that will give us our correct answer of negative 2,112. But now we're going to jump on over into Desmos and show how we could use that to actually solve this really complex question. All right, so if we're going to use Desmos, we still need to understand the basic concepts of our vertex form and being able to spot using that principle of symmetry that 23 and 8 was our vertex. But we can, if we do that, we can write y equals a times x minus 23 to the second plus 8, and we're going to click this add slider button. Now, what we also knew is we also had those 2 points of 21 comma negative 8, and we had that other point of 25 comma negative 8. So here, this is how we can actually use the slider to play a little bit of guess and check, because what we know is that parabola goes through those points. So now I can just play with the slider. It's going to have to be negative, and I'm going to see where I go right through those 2 points here. So we're going to have to zoom in now. We're not quite hitting those points, but right there we can see we hit those points really nicely. So we'll get these kind of points of interest when we're actually intersecting. So now that tells me, okay, my a value is negative 4. Well, now we need to solve for the y-intercept. But we do also need to remember we need to subtract 4 at the end. So we're going to zoom way on out here. I'm going to zoom out even further. And we already know where we're intersecting, but if we didn't, we would just keep kind of coming down here and seeing where we get this nice point of interest again. And we should get one here where we get our 0. There we go. That was our 0, negative 2,108. We would just have to remember to subtract our 4 at the end, and we'd still be able to find that correct answer of negative 2,112. If you've been learning a lot in the video so far and you want to learn everything that you need to know to get a perfect 800 on the SAT math test, I recommend that you check out the free trial to my Ultimate SAT course. And there you're going to be able to check out the entire system of equations chapter from our brand new published digital SAT math book. And you're also going to be able to access all of the lessons, explanations, and Desmos hacks for the system of equations chapter to teach you some of the most important skills to help you get that perfect 800. For groups of 25 or more people, a museum charges $21 per person for the first 25 people and $14 for each additional person, which function f gives the total charge in dollars for a tour group with n people where n is greater than or equal to 25. Now, the tricky part is we're starting basically at 25 and we're going beyond that. So it's almost like we've shifted the y-intercept. There's a little trick for how we set these up, but once you learn it, they're quite easy questions to get right for being so difficult. First thing is we're going to multiply our whole first group. So this is our first 25 people at $21 per person. So we can do our 21 times our 25 plus the price of each additional person after that first group. So it's going to be 14. And now here comes the tricky part. So it's n person, n people. So we're going to do n, but we have to minus whatever the number of people was in the first group because we don't want to start double counting those people. They were being charged $21 for the first 25 people, but we need to take away any double charges that we could have otherwise. So here we're going to end up with f of n is equal to 525 plus 14n minus our 350, and that will leave us with our correct answer of A. Now, if you get to test day and you get to this and you're like, oh, I watched that video, but I can't remember how to solve it, this is a great place where you can use a test trick that I call back solving with points. You're simply going to pick a point that you know is true. So let's just say we're going to do it for, what I would do is just the simplest one, 26 people. So if we're going to do it for 26 people, we know our total charge is going to be 25 times our 21. Let's get rid of my random little mark there. 25 times 21 plus 14 for the 26 person. This is our first 25 people. This is our 26 person. So this is going to give us a total of 539. Now, all you have to do is use your answer choices. And if you plug in 26 for n, the correct answer is going to equal 539. You're just playing a matching game with these values that you know are true. Gives you a really easy workaround if you blank on the setup on test day. In the given system of equations, p is a constant. If the system has no solution, what is the value of p? Well, what we need to understand here is systems of equations are really just lines written in standard form, ax plus by equals c. If they have no solution, they have the exact same slope, but they have different intercepts. Therefore, they're never going to intersect each other, never going to have a solution. Now, when stuff is in this standard form, you can always identify the slope by negative a over b. The reason this works is if we were to solve to put this in y equals mx plus b form, we'd subtract over the ax, divide by b. That would give us our slope of negative a over b. So I'm just going to go through that to make sure I didn't lose anybody there. So we'd have our by equals negative ax plus c. Divide everything by b. That's how we're getting our negative a over b. So this gives us a shortcut that can make this question far easier if we know this little trick. Instead of having to put these all in y equals mx plus b form and most likely making a mistake, we just need to put these in ax plus by equals c form and know that negative a over b will give us the slopes. So I'm going to add over my 3/2 y and I'm going to subtract over my py. So this will end up giving us 6/2 y, which is also just the same as 3y, minus 1/4 x equals 2/3. And on our bottom equation, we'll be left with 1/2 x minus py. I would subtract over my 3/2. So that is going to give us is equal to 6/2, or also just is equal to 3 here. Now, this is why the SAT has intentionally reordered these, is to hopefully lead students into making a mistake if they're going to take this shortcut. So we need to reorder it in ax plus by equals c form, which means we need to flip the order of our first portion here. So we're going to go ahead and do that. We're going to go ahead and rewrite this as negative 1/4 x plus 3y is equal to 2/3. Now what we know is negative a over b gives us the slope. So negative 1/4 over 3 is equal to negative 1/2 over negative p. Now, when I teach this in my book, I just teach it as a over b because the negatives will always cancel each other's out like we just did. Now from here, we just have to cross multiply and solve through. So we're going to cross multiply with our p and our 3 here. And as we do that, I'm going to be left with 1/4 p is equal to 3/2. Divide both sides by 1/4. And that will give me that p is equal to 6, and that will give me the right answer. So if you learn this trick, you're able to really start going through these questions that are supposed to be one of the last questions of the test very, very quickly and efficiently, and it cuts out a ton of mistakes that you normally would make. If a equals c plus d, which of the following is equivalent to the expression x squared minus c squared minus 2cd minus d squared? This stumps almost every student on the test, and we're going to go through the technical way, and then I'm going to blow your mind with how we can actually use Desmos to solve this as well. Now, if you see questions like this, it's almost always what I call a special quadratics question, and this is around your perfect squares of addition, subtraction, or difference of squares. So I'm always looking for those patterns. And what I notice is this is really going to be our perfect squares of addition, but we're going to have to be subtracting this entire expression as we go through. Because if we do c plus d squared, the same way we would do x plus y squared, that's going to get us our c squared plus 2cd plus d squared. Now, if we want to have all of this negative, we simply just need to basically distribute a negative through this entire portion. So we want to be doing x squared minus, if we know that a is equal to c plus d, we want to be doing x squared minus a squared, because since we know a is equal to c plus d squared is also the same as a squared, so a squared also, I'll get rid of that negative that I added in as we were talking through, a squared is also going to equal this same c squared plus 2cd plus d squared, so we just want to get x squared minus a squared, and x plus a times x minus a is going to get us there. That's our difference of squares. That's going to give us x squared minus a squared. X times x gives us our x squared. We know negative a squared is going to give us negative of this entire expression, and that will give us our minus c squared minus 2cd minus d squared. Really, really hard to spot. So let's jump over to Desmos and go through a hack. Now this is actually one of my favorite Desmos hacks. It's just a bit of a trickier version of this, and this is what I call the equivalent hack. If things are equivalent, they're graphically the same. So we just need to start breaking all this stuff down. What we know is we were told that a equals c plus d. Now we're going to have to click add a slider. This is going to just put in values for us. What we set the values to will not affect this question. I recommend just going through this and getting used to some of this yourself. Now what we know is a equals c plus d. We're looking for which of the following is equivalent to the expression, I always graph these as y equals x to the second minus our c to the second minus our 2cd minus d to the second. So this is going to give us this graph. So we'll zoom on out so we get the graph there. Now, if things are equivalent, they're graphically the same. It means they're identical. So we can just also see that c is our correct answer, because if we do y equals x plus a times x minus a, we get the exact same graph. Now we can always tell stuff is equivalent. You turn the graph on and off, gives you the exact same graph. That tells you it's right. Now if we were to try to check a, not the same graph. If we were to try to check b, not the same graph. And if we were to go through and check d, as you will see, this is an amazing hack for the test. Doesn't give us minus a squared, not x squared, excuse me, doesn't give us the same graph. So this is one of the key Desmos hacks that I teach in my book. I'm going to put together an entire Desmos course shortly to go through all the different ways you can take advantage of it for some of these really creative, challenging questions and all the basics. In the given equation, a and b are positive constants. The product of the solutions to the given equation is KAB, where k is a constant. What is the value of k? This is just specific knowledge. Your product of solutions for any quadratic in ax squared plus bx plus c form is always just c over a. So that ax squared plus bx plus c, whenever it's equal to 0 or equal to y, just c over a. So our a value here is 57. Our c value is ab. So we know ab over 57 is the product of our solutions. This is equal to KAB. Well, we can divide both sides by AB. That's going to cancel out the ABs. That's going to leave us with 1 over 57 is equal to K. We're able to find our right answer pretty easily if we just know that correct knowledge. For each real number r, which of the following points lies on the graph of the equation in the xy plane for the given system? Now, one thing we know here is if we plug in our x and y values as we go through each of these, if both sides of these equations are equal, that tells us the point lies on that graph as we're going through. Now, we can go through and we could just manually plug in all of these, and we're eventually going to find the right answer as long as we understand that principle, which means this question isn't nearly as awful as it looks. But we want to be able to identify the right answer really quickly because time is so important on test day. So there's a pattern that comes up with this type of question that lets you jump and find the right answer really quickly. Since everything has to be equivalent, we have to start canceling stuff out. So what I mean by that is I can immediately tell that A is going to be my right answer. And we'll just start by looking at our first one. So when we plug this in, here's our x value, here's our y value. So we're going to get 8r. Pretty easy to figure that out. 8 times x, we're plugging in r for x. So what I'm looking for is I'm looking through each of these answer choices, is canceling everything out. So what I'm doing for y is going to have to cancel out that 8r I just created and make it equal to 9. And that's how I can see this negative 8r over 7, well, plus 7 times, I'll clean up my 7 there, negative 8r over 7, well, 7 and 7 cancel out, 8r, negative 8r cancel out. So we're good there. Plus our 9 over 7, once again, our 7 and 7 cancel out. And now we're going to be left with that 9 is equal to 9 as we go through. So what happens here, we'll write it all out, but 8r, we're going to get plus negative 8r plus 9 is equal to 9. These cancel out. That's how I can find my right answer very quickly. The exact same thing happens when we check our bottom equation. We'll get our 24r. Well, 21 times negative 8/7 is going to give us negative 24. So we're going to create a negative 24r. 21 times 9/7 is going to equal 27. And that's how we can spot our right answer very quickly and efficiently for this type of question. The functions f and g are defined by the given equations, where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? Most students just look at this and have no idea where to start. We're going to make sure you feel really comfortable with all of this. Now, the first thing we need to understand is the basics of exponential growth and decay. So I'm going to pop on the screen a little bit of info from my book here for the basics. But what we need to understand is this is our starting value. This is going to be showing us our increase or decrease, and this is going to be dealing with our powers here. But if we're saying the constant or coefficient is a maximum value, I'm going to pop on some rules from another chapter now. This is how complex of a question this is. The constant be showing a maximum is going to have to be showing that 33 is our y-intercept. And this is why we're going to jump over to Desmos in a minute. And Desmos really is the simplest way that we can solve this is once we understand and we decode all that information, well, if the y-intercept is the greatest value on the graph and it equals 33, that's going to let us see if this question is correct. We can take this super complex question and make it far easier. Now, we're still going to go through the technical way because it actually teaches some really important exponent skills and lets you see how difficult some of these questions are until you understand the Desmos way of doing it. So, as we said, what we're looking for is seeing if the y-intercept is actually 33. Now for both of these, since it's a maximum, it needs to be a decreasing exponential function. If it's less than 1, this is going to be decreasing. So it looks like on first glance, and where the SAT tricks students, is a lot of students look at this and they go, okay, well both of these work. They both have 33 and they're decreasing, but we have something a little sneaky that they're doing with the exponents. So if we take our f of x, we can actually expand this out by writing this as f of x equals 33 times 0.4 to the x times 0.4 to the third. And this 0.4 to the third, when it gets distributed back to our 33, because if we're simplifying this, we need to rewrite this as f of x equals 33 times 0.4 to the third times our 0.4 to the x. Well, this is going to give us something loosely about 2.1 times 0.4 to the x. And going back to our exponential growth and decay, this would be saying our graph is starting at 2.1 and it's showing decrease every unit of x after. But that doesn't show us 33 in this original form, so that does not display as a constant or a coefficient the maximum of the function. So 1 doesn't work. Now as we get to 2, once again, we have some tricky exponent stuff, but this one ends up working because we're going to cancel something out perfectly here. Now as we work through this, we have to expand this back out. So we're going to rewrite this once again as g of x equals 33 times 0.16 times 0.4 to the x times 0.4 to the negative second. Now this is going to be the same as g of x equals 33 times 0.16 times 0.4 to the negative second is the same as 1 over 0.4 squared, which is the same as 1 over 0.16. Put this entire thing in parentheses here. Go back and clean that up so nobody gets confused. And then we'll have our same 0.4 to the x. Now these are going to cancel out, and this is going to give us our form of 33, g of x equals 33 times 0.4 to the x. So this does show us our y-intercept, our maximum value is 33, and it's decreasing by 60% every single increase of x as we go through of the prior term. That's why only 2 works. Now, this is an incredibly difficult question, so as I said, we're going to jump over to Desmos, and if that felt a little tricky, I promise it's going to clear up a lot more as we go there. Now, we can actually use Desmos to solve this question, but we do still need to understand the underlying concept, and here, since we're looking for that maximum, we're looking to see 33 as our y-intercept. So we can just graph this, and if we see 33 as our y-intercept, that's going to tell us that we found the right answer. Now, there's a few things that we need to know about Desmos to graph this properly. Now, you're going to use that little caret button, which is above 6 on most laptops, but if we just try to enter in x plus 3, Desmos isn't going to cooperate. So you're going to have to do parentheses x plus 3, and then we want to set up a restriction where x is greater than or equal to 0. So we're going to use our curly bars. We'll do x is greater than or equal to 0. Close our curly bars. Looks like my mental math was pretty good. We got that y-intercept of about 2.1. Doesn't show us the maximum as a constant or coefficient. So now we'll go over to g of x. Now as we do that, same exact thing. We can simply enter this in. 33 times our 0.16 times our 0.4. 2, once again, use your parentheses, are x minus 2. And when we do that, we'll finish with our curly bars, but you can kind of already see the correct answer here. This gives us that y-intercept of 33 that we're looking for. That shows us the maximum is our constant or coefficient. Desmos can really, really help you out, but you still need to learn the underlying concepts. That's why I always try to integrate Desmos chapter by chapter on how you can apply it in my math course. In the xy plane, a parabola has vertex 9, negative 14 and intersects the x-axis at 2 points. So since my y value is negative, this tells me it's a upwards facing parabola. The equation of the parabola is written in the form y equals ax squared plus bx plus c, where a, b, and c are constants. Which of the following could be the value of a plus b plus c? Well, I can't immediately get to a plus b plus c form, but I can use vertex form to get me there. Now our vertex form is y equals a times our x minus h squared plus k. H is our x coordinate of the vertex, so this is going to be x minus 9 squared, and this is our a over here. And plus k, well, that's negative 14, so we'll have minus 14. So we'll start expanding this out. we'll have y equals a times x squared minus 18x plus 81. I'm just getting that by foiling out x minus 9 times x minus 9. And then we'll have our minus 14. And now I'm going to distribute the a through all of these terms. So we'll have y equals ax squared minus 18ax plus 81a minus 14. And we know this is going to be equivalent to our y equals ax squared plus bx plus c. So what I know is a equals a, negative 18a equals b, and 81a minus 14 is equal to c. So we'll rewrite those statements. A equals a, b equals negative 18a, and c is equal to 81a minus 14. So now we can take this entire a plus b plus c statement, we can just put it in terms of a, so it's easier for us to work through. So that's just going to be, well, a is a, so we're going to do a minus 18a plus our 81a minus 14, and that's going to simplify down to 64a minus 14. And now it's normal to kind of get a little stumped. We've done all this work correctly, but how are we supposed to figure out which of these could be a value of a plus b plus c? Well, we know 64a minus 14 is the same as a plus b plus c. And going back to our first sentence, we know, as we talked about, that our a value here has to be positive as we're going through, because our y coordinate is below the x-axis, and since it's intersecting the x-axis at 2 points, it's an upwards facing parabola as we talked about earlier. So what we therefore know is whichever of these answer choices is correct, when we set it equal to 64a minus 14, it must give us a positive value. And that's why D is our right answer, because if we do 64a minus 14 equals negative 12, well, we add over the 14, we get that 64a is equal to 2, and that's going to give us that a is equal to 1 over 32. Now, if we plugged in negative 14, well, negative 14 plus 14, if we plop in our negative 14 over here, well, we would just get 64a is equal to 0. And that's not going to give us a positive value. And then with the 19 and the negative 20, negative 19 and negative 23, we're going to get negative a values, so we're going to be breaking the rule of that first sentence. This is about as hard of a question as you could ever see on the digital SAT, but if you see really tricky stuff like this, you're probably going to have to reread the question to start picking out little clues that are going to help you know where you should go. I really hope this video helped you out. Now we're going to talk about resources that you can use to better prepare yourself. Now the first thing you may have noticed as we were working through the video is I was popping on the screen where you could learn more about that topic in my new digital SAT math book. So I was popping on the chapter numbers, so if you noticed any topics that you felt deficient in or you wanted more practice in, it'd be great to pick up a copy and just jump straight into those chapters, and then you can start digging into those. We really just kind of scraped the surface for digital SAT math in this video, so there's a lot more advanced question types, a lot of tips and tricks and strategies that you need to learn if you want to get a 750 to 800 on the test. Now the other thing that I would recommend using is my Ultimate SAT course. I've just finished completely revamping it for the new digital SAT. It's already delivered amazing results for international students who've been taking the digital SAT for over a year, and it's delivered amazing results for students in the past. I've had well over 1,000 students use it. It's backed by an 100-point score improvement guarantee. So I would strongly recommend to check out the free trial. You don't need a credit card. You're going to get a few free hours of content. You're going to also get access to the entire Systems of Equations chapter from our new updated SAT math book and all of the lessons and Desmos tricks that I teach there, which is one of the most important ones to learn. You're also going to learn some really important grammar rules. So if you want to check that out, you can see the link below, and I really hope this helped you out.